So any doubts what we have covered till date? Any doubts?
No, sir.
Excuse me.
Yes.
So there was this you had given us. Can we discuss that?
That table?
Yes,
Yes,
sir.
Okay. Wait for a second.
Sir,
Yes.
sir, I had a doubt.
Please ask.
Sir, last lecture you just taught us about thermodynamic pressure and mechanical pressure.
Yes.
So if we talk about thermodynamic temperature and we took an assumption that the liquid rate of the transfer of the heat throughout the liquid solution of whatever it will fluid will be the same. So the thermodynamic temperature should remain constant throughout the fluid.
Thermodynamic temperature? No.
Not temperature, flow. Thermodynamic pressure actually.
Thermodynamic pressure should remain the
constant.
Must remain constant throughout the liquid column we have.
Okay.
Fluid
What is the
column.
reason for that?
Sir, because we have taken we had taken an assumption that the fluid is incompressible, and if fluid is incompressible, then how come and there is no variation in the temperature in the layers. So how come the the thermodynamic properties are not changing when we talk about PV is equal to nRT? Nothing will change in this equation. So how can the P change? Where P shows the P thermodynamic.
So P is actually a local pressure. P thermodynamic is, say, if you have a container here, there is thermodynamic pressure at this location, but you cannot measure that pressure because whenever you go to measurements, you essentially apply the gauge at the boundaries.
Yes, sir.
So wherever you tend to measure, for instance, say, like I think you only gave the example, say I have a stratified fluid. Stratified fluid means I don't have a
velocity.
Stratified means I have variation in energy at each and every location. That is, say, I do it like this. I cover this portion with some sort of cooling air and this portion with some sort of hot air. So this portion is having different amount of energy in terms of its vibration, translation and rotation energy. All the molecules here, molecules will have different forms of energy. So you will have a different thermodynamic pressure from here to here. But under steady state conditions, if they equilibrate among themselves, then the pressures will become similar at all the points.
Yes, sir. It will happen when it will be so the pressure thermodynamic will be almost the same.
Yes, when it is at equilibrium state.
Yes, sir. Sir, and then if we talk about mechanical pressure, it will vary with depth.
It will vary with
depth, as we know, due to the gauge pressure.
Okay. So you are
so then
saying,
how is this possible? The assumption of PT almost equal to P mechanical.
Okay. So now I am showing that. So PT is equal to PM. This means, say, this is, pardon me. Any doubts? So this is the gauge and say this is at height H, say H1. I have another point at height H2. So what will be the pressure at say 1 and pressure at point 2? At point 1 it will be rho G H1. At point 2 it will be rho G H2. Is that clear?
Yes, sir.
Now let me know, in case of this rho GH1 and rho GH2, what will be the thermodynamic pressure at point 1? So this is a mechanical pressure. You measured it using gauge. So these are the values of mechanical pressure. What about thermodynamic pressure at point 1? Do you have, in case of liquids, any equation defining pressure at a point?
Bernoulli.
For instance, you have PV is equal to MRT. This equation is valid for what? Ideal
So
gas?
the ideal states, ideal gases.
Ideal
Yes.
gas. Do you have such kind of characteristic equation for a liquid?
No. We have a differential equation for liquids, I think.
So you cannot actually measure absolute pressure of any liquid. It will be only relative to something. So you can always look at pressures in case of liquids, that how do they vary along the height. You cannot actually define pressure at a location like you could define thermodynamic pressure. That was sum total of all forms of energy. So please remember, in case of liquids, the thermodynamic pressure is not at all even conceivable. You cannot even say that pressure is defined in case of liquids. You have only pressure variation defined in case of liquids. So at location 1 and at location 2, the pressures are rho GH1 and rho GH2. That means these are essentially equal to mechanical pressure, because, and mechanical pressure also not in terms of absolute terms. This is something relative. It depends on the height, and you cannot define pressure. For instance, I say this is a pipe. Here pressure is P1, here pressure is P2. So what do you mean by P1? If I say pressure is P1, it is relative to what?
P2.
P2 or some pre-agreed upon some other reference point?
Yes, sir.
So P1, what you can see is, you can apply, say, I'm putting it here, you want to find out. So please, whosoever has done this kind of drawing, please, if the student can remove that, it will be nice, because it will become much more clearer then.
Sir, if you could turn off your screen sharing and then start it again, it will go away.
Okay, I will do that. Wait for a second. Thank you. So now I'm showing it here. Say I have a pipe here. I want to measure pressure at this location. Say at this location. So what do? I take a small pipe here, drill a hole here. Now when the fluid is, say, in static condition, I'm not considering any kind of fluid flow condition here. Only for simplification, I'm only considering that fluid is stationary, say, and I say pressure is P1. So what does that mean? So what you will see is, you will try to see that up till what point, if there was some kind of mercury here, up till what point has it rise? So if you have something outside, pardon me?
P by rho G.
So this height gives you rho GH, and that is the value of pressure. Or you could simply do it like this. So this one is like this. This one is like this. Say initially both of them were subjective to atmospheric pressure. So they have equal levels. Once you apply some kind of pressure force here, this level goes from here up till here. So you measure the difference between the two and you get the value of rho gh. So you are measuring actually with reference to some standard reference datum plane. Whereas in case of PV is equal to MRT, you can actually define thermodynamic pressure or absolute pressure. So that definition does not apply to liquids. So please remember, you don't have any equation like you have for gases. You don't have any kind of pressure equation, volume equation in case of liquids. You don't have any kind of characteristic liquid equation. Is that clear?
Yes,
Any
sir.
doubts? So I am quickly coming to that table, then we will move forward. So now let me know what were your thoughts about this, filling this table. And you please speak out. I am audible.
Yes, sir.
And what is your take on this? What should I fill here?
According to me, it's asking that thermodynamic pressure is manifested in the form of, I guess,
In
it's
case of
through
solids,
vibrations.
vibrational
It's
mode
through,
only.
yes, sir, vibrational motion alone.
In case of liquids,
It's vibrational, rotational, and translational.
translational of what? Group of molecules, not single.
Masses, yes.
Then polyatomic gas,
So the same with molecules, like vibrational, translational,
vibration, rotational, translation of each and every molecule. What about monatomic gas?
So I think out here it's with atoms.
Vibrational and translation.
Only translation.
Trans-
So that's why,
So
yes,
why not vibrational and why not vibrational?
why not?
Vibrational motion.
In monatomic gas, there are very less chances of getting interaction with others. So there, the only motion that can happen is, that is a maximum probability, that is the translation of the atom itself.
सर हीट इंक्रीज करेंगे और टेम्परेचर इंक्रीज करेंगे तो रैंडमनेस इंक्रीज रहेगी सर, तो स्ट्राइकिंग के चांसेस नहीं बढ़ेंगे.
क्या चीज करने के? When temperature increases, you are saying?
सर जब टेम्परेचर इंक्रीज करेंगे तो फिर मॉलिक्यूल्स इधर उधर ज्यादा जाएंगे, रैंडमनेस बढ़ेगी, तो फिर चांसेस नहीं होंगे कि एक दूसरे से टकराएं.
हाँ, टकराएं तो after getting collision, what will be the predominant motion of those atoms? Because in case of say polyatomic, say I have, for instance, say I have CH4, say methane. Methane is a polyatomic or a monatomic gas?
The polyatomic.
Polyatomic. It means what is happening here is it has something, a kind of this kind of structure. So it can actually rotate also, because this is kind of a body then. So it has rotational energy as well also. Then what can happen? What does vibration mean? Vibration does not, because in case of, if I ask you in case of liquid or sorry, in case of gases, what do you mean by vibration? What do you mean by vibration? In case of solids, you can actually conceive of vibration as they are sitting at their mean position and they are vibrating about their mean position. So that is how you look at solids.
अच्छा सर, मतलब मोनोटॉमिक एटॉमिक गैस में वाइब्रेशन होगा बट ट्रांसलेशन उसको डोमिनेट कर जाएगा.
नहीं, I am saying, say in polyatomic gas, what do you mean by vibration as such?
When they collide with each other, the particles.
What do you mean by
Sir,
vibrate? Vibrate
sir,
means you are
So
at
it's
your
a
own
to or
location.
fro motion. Yes, sir.
You are oscillating about some point.
Right, sir.
So why will you oscillate about that point? If there is kind of force of attraction to bring you back to that location.
Yes.
Otherwise you will not oscillate. Otherwise you will move somewhere else. That's why there is no translational mode in solids, neither rotation mode. So please remember, vibration as defined in gases does not mean that they are vibrating about the same point, because there is very less force of attraction and they don't have any preferred location. So vibration inherently means, if say this was CH4, vibration then means these may actually flap here and there. So then vibration will be defined in terms of vibration or oscillation of this atom with respect to a center atom. Is that clear?
Yes,
Yes,
sir.
sir.
Now it is clear. So in case of monatomic gas, say I have helium. In case of helium, can this kind of relative motion or oscillation happen? Because
No,
there
sir.
is nothing with respect to which it will happen. So that's why in monatomic gases, you have only translational energy.
Sir, I have a question.
Yes. Please ask. And you please ask the question.
Excuse me, sir.
Hanji.
Sir, in solids, but the particles, they can rotate on their own axis.
How?
Uh, so, like particles, atoms, they do rotate.
When do they rotate? When they are subjected to some kind of forces?
Yes, sir.
Under what conditions can they rotate? If you are deforming something,
Sir,
yes.
सर रोटेशन तो तभी डिफाइन होता है ना कि ये कोई रिजिड बॉडी पार्टिकल, तो वही डिफाइन होता है कि
Please
उसमें कोई
speak
रोटेशन
in
नहीं होता है.
English.
हाँ जी पूछिए. हाँ जी, please feel free to ask in any language, because here we are to learn fluid mechanics. It is not a language class. We need to learn the language of fluid mechanics, that is mathematics inherently. So please, if you are not comfortable in this language, feel free to ask in any language and don't shy with that. This is your mother tongue. Don't shy with that. हाँ जी बताइए.
सर पार्टिकल्स तो तभी डिफाइन होता है ना जब उसमें रोटेशन का कोई इम्पोर्टेंस नहीं होता है. तो सर लिक्विड में हम लोग रोटेशन किस रिस्पेक्ट में बोल रहे हैं सर?
Liquids, for instance,
Yes.
say you have seen, you know, water molecule. How does water molecule look like? Or say carbon dioxide molecule. So you have something like this in carbon
Yes, sir.
dioxide. Is that clear?
Yes, sir.
So rotation, what will rotation mean? Say about this point, if this is rotating, so that is the rotation of the molecule itself. That is the rotational energy of the molecule. In case of gases, rotation is when it takes the entire 360 degrees. And vibration in case of such a molecule will happen when? What will happen is, say C was like this was O, this was also O. Now this makes an oscillatory motion like this due to application of some kind of heat or some kind of force. So this is the vibration, how it is defined in case of gases, polyatomic gases. And you clear है आपको?
Yes, sir.
Rotation means the rotation of the entire thing about some axis. And vibration means oscillatory motion about a point. Oscillatory means it will not be a complete rotation, it will be back and forth. And that is what is called vibration in case of gases. Is that clear?
Yes, sir.
Any doubts to anyone?
No, sir.
So I will only take 1 more minute to fill that table, because otherwise we will fall short of time and the syllabus will not be completed. So I will have to take a little bit this table filling very quickly. Otherwise, what we can do is, you can always shoot me an email. I can reply back on that email if you have any detailed queries. So I have clarified this. So can its value be found from equation? So you cannot find thermodynamic pressure from any equation in case of solids, neither liquids. You can find it for polyatomic and monatomic gases. Is that clear?
Yes, sir.
In terms of measurement, you cannot measure any of these as such. What about mechanical pressure?
So for solids, it's so it's translational motion. So on the surface, I don't think so. There is any mechanical pressure on the surface of solid.
Say a book is lying on a table. If I ask you what is the mechanical pressure on the table, how will you find it out?
So the weight of the book upon the area it occupies.
Yes, it is as simple as that.
Okay, so that is the mechanic. Okay.
So you can, because in case of solids, that is the only mechanical pressure that a thing can exert on a body.
Yes, sir.
What about liquids? You have barometers, that is the tubes in which some mercury or some other fluid is filled. Like you measure pressure in case of a glass filled with water, you put a tube here, and whatever is the rise, you say that is the mechanical pressure. Likewise, you have for gases as well.
Right, sir.
Is that clear?
Yes, sir.
So I will move forward now. So what we will do is, now say, now let me know. So any doubts in temperature, pressure, density, volume, and all that stuff? So I will be moving forward now. Now let me know. Now we are actually approaching a more interesting property, and that is, say, surface tension. I'm asking you now 2 questions. Now try to answer those, and that will actually clarify your concepts regarding surface tension then. Say, I have, this is a pond. So in the pond, say you, and water is still. There is no movement of water in this pond. You actually kept a closed loop on the surface of this pond. So this closed loop is, say, somewhat like this. So this is a closed loop you kept on the surface of water in a pond that is still water. Now, some student actually brought a soap.
Who, sir?
Pardon me, what are you saying? What is your query? So should I continue?
Yes, sir. You may continue, sir.
So if I bring, or someone brings a soap and just touches the water surface that is within this loop, what will happen to this loop? So this is the initial condition. And somebody brought a soap and just touched the water surface that is lying within this loop. What will happen to the loop?
Thin film might be formed.
What will be formed?
Thin film of.
Pardon me, what will be formed?
सर एक पतली लेयर बन जाएगी जो पीछे
Layer ban jayegi. Okay.
So the loop will take a circular shape.
So it will take a circular shape. So what is the reason?
सर सरफेस एरिया सबसे कम होता है इसका.
तो साबुन से क्या हुआ? So why after dipping soap in this region, this changed to this particular shape? And you can try this at home also. It will be a very interesting experiment. You can try out at your home today itself, and then try to see why it is so.
Sir, what's STIU, sir, here?
Pardon me, what are you saying?
still water.
Oh, still water.
So
Oh,
what you can do is you can take a glass of water, and in a glass of water, water is still only. Simply put a thread here on the surface of water, and then bring a soap to touch this water, which is within this loop. What you will see is the loop will take a preferred orientation, that is a circle.
Sir, in a circle, equal area is exerted on every part of its perimeter. That's why it's taking circular form.
So the reason here is surface tension. And what is happening is when you have soap here, it actually reduces the surface tension in this region. So because surface tension has reduced, and surface tension here is larger as compared to within the loop, so it pulls the loop in all directions equally, and that makes this loop a circle. So reduction in surface tension actually makes this shape from arbitrary shape to a circle. Himmat, you have raised the hand. What is your query? Any query?
सर जो सोप है वो सरफेस टेंशन मतलब रिड्यूस कर देता है.
हाँ, surface tension reduce कर देता है. Surface tension क्या होता है? It is the cohesive force between water molecules. So what is happening is whenever there is a free surface समझते हैं आप लोग?
Yes, sir.
Whenever you have a glass of water, there is a surface that separates air from water. All of you must have seen that. That surface is called free surface. And I think in your 9th and 10th classes, you might have observed that there is a kind of, this surface is just like a stretched membrane. That is, this actually acts like a border and does not allow something to get in. There's kind of pull in all the directions. So it is like a stretched membrane. So the stretching happens due to the fact, for instance, I take a molecule here. Now let me know, this molecule is being attracted by all other molecules that are around equally. Any doubts? So this molecule is being attracted by all other molecules. But what happens to a molecule that is at the surface? What will happen?
सर एयर के जो पार्टिकल्स हो वो भी अट्रैक्ट करेंगे.
तो इसका एक part is being attracted by air and other part is being attracted by. So what you can see is I am drawing here. Now try to see. So this is the condition for a surface molecule. And this is the condition for a molecule which is at the interior. So it is being attracted in all directions, whereas in case of surface, the molecule is being attracted only in one particular direction. That's why you have a net force pulling downwards or stretching here. So that is called your surface tension. And now what happens is, when you have actually put soap here, those soap molecules start interacting with the water molecules. So the cohesion force within the water molecules actually reduces. And that leads to reduction in surface tension force within this region, whereas in the region outside, there is still no effect of soap. So this pulls the string outside and you get a circular shape. Now is that clear?
एक बार दोबारा बताओ,
कहाँ से आप बताइए?
जो भी आपने लास्ट लाइन रिपीट करी है।
ये समझ आ गया दोनों मॉलिक्यूल्स का, जो सरफेस पे और जो इंटीरियर में?
यस सर, ये आ गया।
ठीक है, अब जो सरफेस पे मॉलिक्यूल्स हैं,
ये जो सरफेस पे आपने जो बनाया है वो मॉलिक्यूल का अट्रैक्शन से सिर्फ वाटर के रिस्पेक्ट में ना, एयर के रिस्पेक्ट में नहीं है ना वो?
नहीं, पता है क्या, जैसे अब ये यहाँ पे वाटर के रिस्पेक्ट में मैंने बना दिया, ये ठीक है ना, वाटर का रिस्पेक्ट है जो ये आपके सरफेस टेंशन है। अब बाहर से भी कुछ इंटरेक्शन होगी, उसको बोलते हैं एडहेशन। अब एयर के मॉलिक्यूल्स की इससे इंटरेक्शन बहुत कम है, इट इज वेरी फीबल, सो यू कुड एक्चुअली ड्रॉ इट लाइक दिस। सो व्हाट विल हैपन इज दिस विल बी very small magnitude. So net force will be in which direction? Either in this direction, this direction. So it will be towards the liquid, because adhesion force with the air molecules is very low as compared to the cohesive force within similar water molecules. So please remember, cohesion is force of intermolecular force of attraction between similar, and adhesion is,
Excuse me, sir.
dissimilar. Yes. Please ask.
सर कोहेशन फोर्स सोप के इंट्रोडक्शन से कोहेशन फोर्स रिड्यूस क्यों हो जाती है?
सोप के इंट्रोडक्शन से क्या होता है?
कोहेसिव फोर्स रिड्यूस क्यों हो जाती है जो वो
सोप के अंदर होती है? फॉर इंस्टेंस, से आपका एक फ्रेंड्स का ग्रुप है, say 2 friends are there or 4-5 friends are there, say they are of same branch.
कौन? Yes sir.
ठीक है, they are same branch or same class. You know the chemistry of each other, and say some other student from some other class or some other college comes to your class. Will that impact your own interactions between or among yourself or not?
No sir, it will not impact.
If say this person is very much say proactive, he tends to help everyone.
Yes sir.
So what will happen? You will also try to interact with this person.
Yes sir.
So in the process, what will happen? Your mutual interaction with other similar molecules will actually reduce. If this person is say,
yes sir,
very helpful,
Yes, sir.
so what will happen?
Yes,
the unity will break.
Sir, but
Yes, sir.
how we are
Yes, sir.
relating molecules and students?
Molecules and students, I am relating not in a literal way. What I am saying is, these water molecules that were there originally before the soap was dipped, they were having attractive forces among themselves. So that is clear. So some foreign element came in, and that foreign element tried to make bond with the water molecules. So when it will try to make bond with the water molecules, so if you want to, if the existing water molecule wants to make a bond with the new molecule of soap, it will have to actually detach or reduce its interaction with the surrounding water molecules, which were originally in interaction with that molecule. So the force of cohesion between water molecules has somehow reduced due to entry of some foreign molecule. Now your question is very interesting. Say a person comes which is not at all well behaved, not at all helpful, will the surface tension change or not?
No.
No. So please remember, any foreign particle cannot reduce the surface tension. Only certain atoms or molecules which actually make bonds with the water molecules, they will affect the surface tension or the cohesion force. आप समझ रहे हैं? आपकी फैमिली में, आप घर में बैठे हो, अगर कोई बाहर कोई बहुत ही गुंडा आया है तो आपके
सर घर पे नहीं, सोफे पे बैठे हैं।
हाँ जी, क्या कह रहे हैं आप? हाँ जी, प्लीज, व्हाट इज योर क्वेश्चन? सो प्लीज आस्क। सो एनी डाउट?
सर।
हाँ जी। सो सरफेस टेंशन or cohesion force will also depend on the nature of foreign particle. So please, this thing should be remembered. That's why we say soap reduces surface tension. So it does not mean any kind of other material will also reduce the surface tension. So that should be clear in your minds. Any doubts?
No.
So next is,
सर वो जो आप लास्ट वाला एग्जांपल समझा रहे थे वो थोड़ा क्लियर नहीं हो पाया था।
कौन से वाला?
सर जो कोहेशन फोर्स रिड्यूस क्यों हो जाती है, वो
आप
लास्ट में
मेरी
आप
बात
एक
समझिए।
एग्जांपल
मान
समझा रहे थे।
लीजिए, मैं एग्जांपल क्या कह रहा हूँ, जैसे ये मेरे पास मान लीजिए एग्जांपल है, आपको ये रिएक्शन बताइए। जैसे ये H2O है मेरे पास, से दिस इज H2O, या इसको हम ऐसे बोल रहे हैं, एग्जांपल H2O है, इसके अंदर से so what is happening is, say the bond between HOOH and the corresponding, ये लीजिए मैं यहाँ पे ऐसे लिखता हूँ, ये O है, ये मान लीजिए H है, this is H, and say this is also bonded to another molecule. So I'm showing the another molecule with this different color. Say these are two molecules, and this is again connected to a third molecule which may be still of different color. Now, so these are the say molecules that are present on the surface. So these are the molecules that are present on the surface. Now they are having force of attraction between each other, among themselves. So say the water molecule is being infiltrated with some foreign particle of say soap. So what will happen? This soap molecule may tend to interact with this red. So this is say F, foreign molecule. So this tends to attract with this. So when this water molecules is finding it congenial that this foreign particle is worth to interact, its interaction with other two water molecules will little bit reduce. So the cohesion force has reduced among the water molecules due to entry of this foreign molecule. And if
सर यही रीजन होता है झाग बनने का पानी में?
यही रीजन होता है
पानी में लेदर बनने का।
किसमें लेदर बनने का?
सर वाटर में जो लेदर नहीं बन जाता सोप से,
हाँ,
यही रीजन होता है उसका?
नहीं, वाटर में आप ये कह सकते हो वाटर में जो वो डर्ट हटाता है उसका रीजन ये हो। सरफेस टेंशन रिड्यूस करता है, क्या होता है कि सरफेस टेंशन उससे क्या होता है, बेसिकली जो डर्ट पार्टिकल है, जो सोप मॉलिक्यूल है, वो एक पार्ट डर्ट से कनेक्ट कर लेता है, दूसरा पार्ट वाटर से कनेक्ट होता है, तो डर्ट को निकाल पाता है वो।
ओके सर।
तो सरफेस टेंशन रिड्यूस करता है ताकि वो पानी उस डर्ट पे डर्ट निकाल पाए उस कपड़े में से.
Yes, sir.
So this is the phenomena that's why we use surface tension force in terms of surf or any kind of soap that reduces the surface tension, and it helps in taking out the dirt molecules from the particular cloth. And that's why you wash your hands. So when you wash your hands, what happens is, wash your hands with a soap, the surface tension is reduced, and the foreign molecules on your palm can actually get attracted to those surfactant molecules, and in the process they get washed away from your hand. And that's why we wash our hands in these COVID times very frequently, so that any molecule or any kind of virus if it is there on our hand, the surface tension force can get reduced due to that soap, and that molecule can actually get away. So that was all about surface tension. There's another property that is called capillary action. So please remember, surface tension was due to cohesion forces. Capillary action is due to adhesion forces.